Okay, hello. So this is part 2 of the video I'm doing on the AS paper. Pretty big. There we go. And you can have a look at this again. I'm gathering that this probably wasn't a popular question, although I actually quite like it. I prefer it to the last one on the roots of quartic. I actually really do. I find this one slightly easier than that. Now, this first part is very standard kind of stuff. Yeah, you use standard results, or for the sum of r squared, the sum of r, sum of k, etc., etc. Now, worth quickly writing down sum of r squared. I can't remember if you get these in the formula book or not, but maybe one or two of them, I don't know. But it's n over 6 m plus 1 2m plus 1. I normally write it down in a different order, so I've confused myself. It's cubic when you add the sum of the squares, so you can see it's cubic, but yeah, you get a 6n m plus 1 2m plus 1. Sum of r is just some of the triangle numbers, isn't it? Some of the natural numbers, sorry, which happen to be triangle numbers. And the formula for triangular numbers is n plus 1 over 2. And then if you ever sum a constant from 1 to n, it's just kn. So that's what I'm going to use, those three results. Funnily enough, first time I did this, and you can see I'll keep all my original answers nice and clear. I made a careless error, but I managed to detect the error later on when things didn't work out nicely. So it shows, you know, like error correction is a massive part, especially in a tough paper like this. It's a massive part of what you do. So 3 times sum of r squared from 1 to n minus 17 sum of r from 1 to n, and then 1 to n 25. So we're just going to plug in the formulas. That's 3 over 6, which is a half nm plus 1 2m plus 1. Then minus 17nn plus 1 over 2 minus 25n. Best thing to do is factorise as early as possible. Make that 50n. Then you can take out a half from everything and an n from everything. Then you've got n plus 1 2m plus 1 minus 17m plus 1 minus 50. Then you've got this, which rearranges to this. You can see where I went wrong actually earlier. I did minus 17 minus 50 is minus 57, dear oh dear. But it's actually minus 67. When you add 1, it's minus 66, so you get minus 33 here. It was a problem later on in the question where I realised, hang on a second, this isn't working out nice. Oh my god, I've done the easy bit wrong, which is fairly typical. It's easy to do the easy bits wrong, it really is. You know, start of a question, adrenaline pumping, you go and get it wrong. Now, B I like, but only because it's a fun question in maths. And I tell you what, they're doing this in single maths as well. They have like sines and coses in these sigmas, and they're just expecting you to see a periodic pattern. There's a periodic pattern in here. You've got a calculator, so you should be able to see it. Now, always, when you've got a difficult sigma to deal with, try and write down the first few terms. So we've got 1 times tan 60, plus 2 times tan 120, plus 3 times tan 180, plus 4 times tan, what's the next one, 240, plus 5 times tan 300, plus 6 times tan 360, so on and so forth. Now, every time you hit a multiple of 180, you're going to get 0. And that's because, think of the tan graph. It goes through the origin, and it repeats every 180. So it's going to be 0 at 0, 180, 360. Or think of tan as sine over cos, and sine is 0 at 0, 180, 360, so on and so forth. So every third term, every time you get 180 or 360 or 540 or so on and so forth, every third term is going to be 0, yeah? And so it's only the first term, the second term, the fourth term, the fifth term, the seventh term, the eighth term, which matter. Now, tan of 60 is root 3. 2 tan 120, well, what tan of 120 is the negative tan 60, so you get negative root 3 in general, and I think this is worth writing down, this formula, minus tan x is tan 180 minus x, yeah? I could prove that, I suppose, with the compound angle formulae. When you do tan of a minus b, I don't know if you've done this yet, but you get tan a minus tan b over 1 plus tan a tan b. My students would have done this just because they do the all the single maths first. So here, what have we got here? We've got tan 180 minus x. Just to prove to you that it's minus tan x, what you're going to get is, using the compound angle for tan 180, which is 0, minus tan x. There you go, there's a negative tan x. And then 1 plus 0 times tan x. and so it does equal, as that completely disappears, and that's 0, you get minus tan x. So there we go. So that's a useful trig identity to know. And I'm aware if you're only doing AS Maths and AS Further, this paper's going to be extremely difficult. It's much easier if you've done all of the single maths. Anyway, you could have just asked your calculator, I suppose, and you would have seen that's minus root 3 times 2. So you've got root 3 minus 2 root 3 plus 0. Then you're going to get 4 root 3 minus 5 root 3 plus 0 plus 6 root 3, plus 7 root 3 minus 8 root 3 plus 0. But each time, when you do that minus that, you get a negative root 3, because root 3 minus 2 root 3 is minus root 3. 4 root 3 minus 5 root 3 is minus root 3. And you're going to get that, because you're going to get these occurring in triples, you're going to get k of those. That's going to happen k times. And what's k times minus root 3 plus minus root 3 plus minus root 3? K times. It's minus k root 3. Now, I hope I've shown enough to get the marks there. I often think, you know, it's only worth 2 marks, so how much I've got to explain. I would have thought that would convince an examiner this kid knows what they're talking about. I hope so. So that was part B. Now, part C, I'm just going to turn to the page I've done over here because I haven't photocopied all of this. This is quite hard, but it's not impossible. So let's do this. Okay, so what have we got here? I'm going to look at the left-hand side and then I'm going to look at the right-hand side because I'd rather just, I can see r equals 5, this one's starting at 6. It looks stressful, yeah? So break it up, make it digestible. So I'm going to start with, I think I started with the right-hand side just because I was quite excited to work with a tan. You've got 15, open bracket. Now, I immediately rewrite this as 1 to the 3n r tan 60r minus sigma of 1 to 5 r tan 60r. And that's because, look, it doesn't start on 1. You've got to deal with that. You've got to deal with that. And then I close the brackets and squared it. Yeah? And, you know, I'm looking at this, I'm like, blimey, that's hard. You know, like, they're not going to like this for students. That, you know, just straight away you can see, you get to learn what is off-putting for students, and I can see why you didn't like that. Okay, but I've got a formula for this one. I've just discovered a formula that this is going to be equal to, let's have a look at the formula, it's going to be equal to minus k root 3. So here, because we've got n's instead of k's, this is going to be minus n root 3. Cool. And then this is just the first 5 terms. Well, didn't I write out the first 5 terms of this? I'm sure I had it down here, didn't I? 1, 2, 3, 4, 5. So I've just got to add up these first 5 terms, and this comes to minus 2 root 3. Now, it's important to notice that that is going to be minus 2 root 3. So that becomes plus 2 root 3. And so you've got 15, take out the root 3, you're going to have 2 minus n, and then we're going to be squaring that. So that's going to be 15 times 3, which is 45, 2 minus n squared. Got it in a lovely, neat format. Very happy with myself. Very happy. Okay, left-hand side. That's this. This will be easier. This was the one which didn't interest me as much because it looks a bit, you know, so I did this one after. I like to do the fun stuff first. Okay, from 1 to n, and I do not consider modelling fun stuff. 3r squared minus 17r minus 25 minus from 1 to 4 because it started from 5, 3r squared minus 17r minus 25. One of the reasons I am sympathetic though, and I say this to everyone, is this is much harder than the ones they give you in the book. And you know, what's the point in having the book if it's not giving the questions at the same level of difficulty as the you know as the paper does? You kind of think, come on, you know, Edexcel, that's not fair, is it? Make the book harder if you're going to make the paper this hard. Okay, so I've just plugged in here n is 4 into this formula because it's just the first 4 terms, and then I'm just going to simplify it. So I just get, that ends up actually being plus 180. So I get n cubed minus 7n squared minus 33n plus 180. Yeah? Now, they said the left-hand side equals the right-hand side. So let's actually use that. What we're going to have is 45, 2 minus n squared equals n cubed minus 7n squared minus 33n plus 180. Multiply all of this out, n squared minus 4n plus 4. You'll notice that the 180's cancelled. As at that point I thought, oh, I might actually have a chance of solving this now. The 180's cancelled. I suppose you've always got a calculator which solves cubics, haven't you? But anyway, once you take it all onto this side, you end up with n cubed minus 52n squared, and then you're going to have plus 147n. I'm just checking that this is right. Yeah, that's, yeah, plus 147n. I think that's right. Yeah. Cool. Sorry, yeah, I was looking at the wrong thing. I got kind of suddenly slightly perturbed. I thought I'd done it wrong. Okay, take out the n, and then it's just a quadratic. Factorise n minus 49, n minus 3. And so you could have n is 3, or you could have n is 49. I wonder if there's an easier way of doing that, if there's something else I should have spotted. Let me know in the comments if you've got a better way of doing things. Always interested in that. I'm not the font of all knowledge. I definitely make mistakes in maths. I definitely clown things up. Ask my classes, they'll tell you. Why is this getting bigger every time? Okay, eventually this is going to look clearer, I hope, because at the moment I can't read it. This is a, what happened to the old vectors questions? When I saw this, it's like, I used to do so much. My students have gone through, like, working with planes, lines hitting planes, angles, all that kind of stuff. They've probably memorised God knows how many formulas. And then they get this question, yeah? And you can't help but think as a teacher, so I prepared them for the wrong paper then, did I? Because where's the vectors in this paper? They would have worked so hard on, like, all the typical kind of vectors questions of the style that they used to give. They don't have anything like this in the textbook, like nothing. Like, what are Edexcel playing at? That Pearson textbook should be, I love books, but, it's one of the few books I would be tempted to burn. Okay, so, let's have a look at this. We've got a tennis court. And the thing is with this question, actually, it's only intimidating on the facade. If you actually get what it's saying, I don't think it's that bad, actually. Now, I and J, it's important to draw a diagram here. I and J are like the horizontal plane of the tennis court, yeah? It's K, which is like the height, as it says here. K is the height vertically upwards. And if like the person's serving in the air, that's kind of like, whilst K is going to be positive up from the ground, like that, but that's what we're dealing with here. So K is its vertical height, which is really important in this question. I think I got this question right as well, because of something which happened at the end, which made me think, they've kind of helped you check your answer there. Now, what have we got here? The tennis ball is hit, it travels on that path. Assuming the tennis ball continues on this path until it hits the ground, find the value of lambda when it hits the ground. Well, that's what it's going to be when the coefficient of K is 0. So I had 0.84 plus 0.8 lambda minus lambda squared equals 0. I solved it on a calculator, and the only positive value I got was lambda is 1.4. Yeah, I got a negative value, but as they say, lambda's got to be positive. So that wasn't too bad. Part B. Okay, this is the direction the ball is moving in. The way I see it, direction is velocity, yeah? I really do see velocity and direction as the same kind of thing. Direction is velocity, position is very different to direction, yeah? It's not the same thing. This is the direction the ball is moving in. And they want us to write down the direction in which the tennis ball is moving as it hits the ground. So I'm just going to plug lambda equals 1.4 into that. And I get, the direction is, now I just plugged it in, I'm getting 2.56, 15 and minus 2. Let me know if I've actually plugged that in right. I think I've plugged it in right. Maybe I should just quickly do it again. Let's just quickly do it again. 9 minus 4.6 times 1.4, 2.56, yeah, that's good. 15's fine, and then 0.8 minus 2 times 1.4, because the next question depends on this, you get minus 2. Good. Okay, so Hence find the acute angle that the tennis ball makes with the ground. Well, yeah, this requires, I think, a bit of thought and a decent diagram. Basically, what direction is your ball moving in? Let's take this as like the I direction, and that's like 2.56. But then let's draw the J direction kind of like this, and it's like 15. And then let's do the K direction when it's straight down, like that, yeah? And this is almost like a 3D trig question in Pythagoras, because what we've really got to do here, if we're trying to find the direction, is work out the angle it makes with the ground, yeah? Now, if I draw it out like that, I'm actually really pleased with that diagram. Because it's 2 down, I've just put it as 2 there, yeah? If we can find this length here, which is just Pythagoras, and I think it comes to 15.22 if you do it with Pythagoras. So I'm just going to do Pythagoras to work that out, and it came to 15.22. What I can then do is find the angle it hits the ground, because that angle there will be the same as on the ground this angle here, because it forms a Z angle, and like you don't need the Z angle, that's just going to be the angle, the acute angle the direction of the ball makes with the ground, yeah, because you have to have it as like perpendicular to the ground. And so what we've got here therefore is a triangle with that as 15, that as 2, and that as 15.22, and then you can do it with tan theta equals 2 over 15.22, and that gives you theta is 7.5 degrees. I think they specified to 1 decimal place. I think if you use 15 rather than 15.22, it comes to 7.6, so they can tell if you've done it wrong, basically. But yeah, that's part C. Quite a tricky one, that one. Okay, but you didn't need it for anything else in the question, so if you didn't get that one right, it's not the end of the world. Okay, the net of the tennis course, light is in the plane, r.j equals 0. Now that r is not the same as the r they used earlier. Yeah, r is just a general point. It stands for like, you know, x, y, z really. And so what we've really got here is x, y, z dotted with 0, 1, 0 equals 0. Or in other words, y equals 0. That's the plane you're dealing with, y equals 0. Now this was on an earlier question. They said, you know, if I could just quickly draw x, y, z out like this, I'll put y there this time. Yeah, because this works quite nicely. The plane y equals 0 is like the x and z axis. Yeah, if you see what I mean. It's the plane which x and z lie in. That is the plane where y equals 0. But once you've got that y equals 0, it's relatively easy to find the position of the tennis ball at the point where it is in the same plane as the net, because we just turn to the position formula, and the position formula is up here. We're going to set y equal to 0, in other words, minus 10.25 plus 15 lambda equals 0. We're going to solve that to find that lambda is 41 over 60, and then we're going to plug that in to all of these things here, and I think you get some ugly numbers, which doesn't help students in an exam. 0.976, 0, 0.92, yeah, for your x components and your z components for the position. Yeah. Now I suddenly thought when it said that, I've got that as my position. When it said state whether the tennis ball will pass over the net, bearing in mind the net is 0.9 meters and all of these are in meters, I thought, yeah, it's probably right, because look, it just passes over the net. But it also gave me something to say here, because in part C, when it said with reference to the model, does the ball pass over the net, my initial reaction was, I just told you that, it passes over the net. You know, like, what are you talking about, Edexcel? What are you going on about now? But I thought, no, what they want us to talk about is the ball was modeled as a particle. Now, how big is a tennis ball? Maybe about 8 centimeters, yeah? And it passes over the net by 2 centimeters. Well, it depends whether you're modeling, you know, I would suggest that probably the middle of the tennis ball is going to be the center of the particle, yeah? And so what I said was, not necessarily, as the ball is modeled as a particle, which is false. and I actually said tennis balls about maybe 8 centimeters wide. Is 8 centimeters, so it could catch on the net. I don't know, I really don't know. Maybe you've got enough momentum to get over it, but you know, if you really spank it, but it could pass over the net. It could fail to pass over the net. But honestly, I feel sorry for everyone there. I bet you worked on loads and loads of questions on vectors which were nothing like that. Yeah. So basically, you prepared for a question which was, you prepared for questions which are nothing like this. There's loads of pure maths vectors questions which are nothing like that, but Edexcel are obsessed with modelling. You know, that's why we're, as a department, thinking about possibly even, changing exam boards. Like, I've had casual conversations anyway about that, but like, what are Edexcel doing? If you're listening, Edexcel, seriously, at least set them questions which are similar to the ones in your textbooks which you wrote, Anyway, next question. This one I'm going to fly through because I bet you this was the one on the paper where you were like, at least I got 6 marks there. Like, if you thought the paper didn't go so well anyway, I bet you thought this question went well because it's typical. Yeah. Now, don't get me wrong. Not all the paper should be easy like this, but like this is a typical induction question. That said, students don't normally like induction, but I would have liked to have seen a difficult proof by induction or more tricky one. But there we go. The matrix ones aren't that bad. So base case n equals 1. Make it clear that you've expressed that the left hand side is the same and the right hand side. Actually show n being plugged in as 1. And so the result holds for n equals 1. Assume true for n equals k. You must write assume true for n equals k. Yeah. Don't not write it, or well, I suppose if you don't want 6 marks, you don't have to write it. But if you want 6 marks, write. Then assume this result is true for n equals k. And what you're really saying there is that for some number n, which we're calling k, the result holds. And then you're going to say, well, what about the next number after that? Well, that's k plus 1. Well, if we use this as minus 5, 9, minus 4, 7 times k, to the power of k times by itself once more, we can then use the assumed result, which you always need to do in induction. If you don't use the result you assume true, you're doing it wrong. And then multiply it out. What I always do when I do induction is I write down in a little bubble what I'm looking for, yeah, or what I'm hoping to get. It's not part of my argument, but it's like, well, this is the result of k plus 1 substituted for k. And sure enough, I get this, and this is just the result of k plus 1 sub for k. Maybe, I know in the book, they're keen on actually writing it as minus 5 minus 6 times, or well, I think they write it down like this. They write this 1 minus 6k plus 1, and then 9k plus 1. It's probably a good idea to do this at the end. Minus 4k plus 1, just so they can see that it is indeed the result substituted with k plus 1 for k. And then you can say, hence true for n equals k implies that it's going to be also true for n equals k plus 1. I often do a longer sentence than this. I say, so the result holds for, if the result holds for n is k, then the result must hold for n is k plus 1. In other words, if it holds for one number, it holds for the next number, and as it holds for the very first number, n is 1, it's true for all n by induction. But that's probably the nicest question on the paper. Right, let's do the bad boy then, the volume of revolution question, which was, I mean, once again, I don't mind them testing volumes of revolution. It's part of the course. Of course they should test it. But so much of this question isn't about volumes of revolution. And then the integration at the end, unless I'm missing something, it's like a really, really long one, like with horrible fiddly numbers. But tell me, maybe I've got it wrong. Maybe I'm doing something wrong. Let me know in the answers if, in the comments, sorry, that I'm doing it wrong and I'm an idiot. I'm quite happy to accept that. It's happened many times. Okay, so we've got this vase, and the side of it is modelled here. And these are all A's. So straight away, state the value of A that should be used when setting up the model. Well, as the diameter is 8, that means the radius, we're only going to be dealing with half of this, is going to be 4. And so A equals 4. Yeah? And that's not too bad, provided you realise you've just got half the vase. And you can just write that down. Okay, and then they suggest 2 possible models. Okay, fair enough. But this model is in degrees, and I even saw somebody on the student room forum saying, I don't know how to differentiate trig functions. Now, firstly, differentiating trig functions in degrees, don't do that. Just don't do that. It's never. Just don't do it. It's not difficult actually. You can just transfer, a function which converts the degrees into radians in here, and then you can differentiate it. But sin x does not differentiate to cos x if you're in degrees, and so I wouldn't be differentiating that. That's something I'd straight away say. There's a better way of doing it, and we're going to look at that in a second. But anyway, for each of these models, bearing in mind we already know as 4, we've got to work out the distance. We're basically working out this peak here. Yeah, we're going to find the distance from the base at which it's widest, so that's at that peak. So this, we're going to work out that distance there from the base, and we're going to work out the diameter, in other words the height. Yeah, in other words, we're going to work out x and y here at that maximum. Yeah, so I can understand why you were thinking differentiation. Yeah, and I differentiated in model B. I definitely did. Once again, it's not particularly straightforward, but it's easier than the sin x one. But the best way of doing sin x is to use the periodicity of the peaks and troughs of sine, no doubt about it. So let's look at model A first. This is the way I wanted to set up my answer. If I'm trying to find that coordinate on model A, and model A has the equation y equals 4 minus 2 sine 45x over 2. First thing I thought was, how do you get from sin x to this function? Yeah, well, sin x, let's draw the negative side as well, because we only need that and that really. Sin x looks like that, just normal sin x in degrees, with that being 90, no, with that being 90, that being 180, etc, etc. Yeah. Now what's interesting here is that's at minus 90. That's the interesting bit to me. Yeah. So if I want to find the coordinates of this bit here, let's try and do function transformations to get there. Yeah. Firstly, if I change it to sine of 45x over 2, that's just like a stretch of 1 over 45 over 2 in the x direction, which I'm not going to actually bother with the numbers. Actually, I'm not going to change the numbers because I've got a better way of doing it. I'm just going to basically show it stretch. I'm not going to put the scale on. It doesn't really do anything. It just stretches it a bit. So this will have different numbers on the x-axis. And then y equals 2 sine like that. Well, now it's just going up to 2 and down to minus 2. What about if I change the sign? Well, now I've made all the y coordinates turn from positive to negative, and so that would be y equals minus 2 sine of some stuff. Yeah? And then finally I'm going to add 4, which is why this isn't going through the origin, it's going through 0, 4. Yeah? And if I add 4, I'm suddenly going to be, with my bars, like that, yeah? And so this is y equals 4 minus 2 sine 45x over 2. So I kind of did this in my head, because now if I want this, well, I obviously want the bit which makes sine of the stuff minus 1, yeah? In other words, I want, as basically sine of minus 90 is minus 1, remember that on the first graph? Let's go back to it. Sine of minus 90 is minus 1, yeah? I want that to be minus 90. And so now I can work everything out from that. Firstly, the y coordinate is just going to be 4 minus 2, which is 6, yeah? Because I want sine to be basically, sine of the stuff to be minus 1, so I can find this bit here. And then 45x over 2, well, that's going to be minus 90, because sine of minus 90 is minus 1, and therefore I got x is minus 4, because minus 4 times, yeah, you'll see it works out. Okay, so I've got it now. I can say the distance from the base is actually 4, because it's minus 8 the base. If you look at the picture, that's at minus 8. I got this as minus 4, so that's going to be a distance of 4, and this is 6, so the diameter is going to be 12 at the widest bit. There we go, 4 and 12. So not too bad, provided you're really comfortable with transforming trig functions. And I find it quite comfortable transforming those kind of trig functions. They're very common. Once again, this is a question for people who have done A2 maths. If you've only done AS maths and AS further maths here, that'll be, I think, quite a tough question for you, really. But there we go. Okay, next question. Sorry. Okay, so model B. I'm going to do the same for model B. Now, here I did differentiate, I'll be honest with you. I was just like, okay, I'll differentiate this one because I don't feel too bad differentiating it. Even though it's cubic on the top, you see you get x times x squared minus 64 over 100. And so that is y equals 4 minus x cubed minus 64x over 100. Now, when you differentiate this, that goes to 0. Was it plus or minus? I can't remember. Plus, sorry. So let me just change that. I do that all the time. Miscopying questions. Who makes mistakes miscopying questions? I do. I personally leave the constant outside and just differentiate in here. And that's because constants in calculus just hang around, basically. Not constants like that, not terms independent of x. But if you've ever got like 7x cubed, what you can do with a 7 when you differentiate is not very much. You can just do 7 times 3x squared and then you times it in at the end, 21x squared. Well, it's the same as 100th x cubed minus 64x. You just leave the 100th outside. And now we're finding a maximum, so we're going to set it equal to 0. And then I'm just going to solve that, times 100 over, add the 64, divide by 3 square root. So you get x is square root of 64 over 3. Personally, I checked what value that actually was. Now remember, this is a plus or minus, and we need the minus one. Yeah, so whatever that is, I can't remember exactly what it is. Oh, minus 4.62. Yeah, so that's going to be minus 4.62 back there, and I'll need to do 8 take away 4.62 to find the distance from the base, if you see what I mean. So I want the minus 4.62, so the distance from base is actually equal to, you know, the gap between negative 4.62 and negative 8, which is 3.38, is it? Roughly speaking. Yeah. We now need y. Just plug it in again to find y. Make sure you plug in minus root 64 over 3. I almost made that mistake. I got y equals 5.97. At this point, I thought I'm probably doing it right because I got very similar to answers to the other model. Yeah. So the diameter is almost 12. Look at that. And especially with what the question said next, maybe I'm wrong though, let me know if I'm wrong. With what the question said next, I thought, well, I've got very similar figures to that, because using this information, make your reasoning clear, suggest which model is more appropriate. Well, it's told us it's just over 3 centimetres from the base. That looks like this one. Yeah, they want us to use model B. So model B is just over 3 centimetres from base. But model A isn't. But model A is 4. So use model B. Both are very close to the 12. Well, you know, like 11.94 isn't far off. Okay, so we've done that. Okay, and the last bit of the question, I'm just rushing now because, you know, I want to get some sleep in a minute. Using algebraic integration, find the volume for the vase predicted by model B. You must make your method clear. Now, I really, really, really wonder here if it's, in fact, I'm going to do some Edexcel examining. After doing this paper, it's like I want to do some Edexcel examining because I want to know if you can get away with doing something here. Now, we're revolving this around the x-axis, and the formula for a volume of revolution is integrate pi y squared dx, yeah, between the limits of -8 and 8, yeah. Now, y squared, look at this, y squared, got to square all that. Well, that's going to be really ugly. So you get pi times, first thing I did was I made this 400 plus, now what did I have, 400 plus x cubed minus 64x over 100. So I put the 4 in the fraction, if you see what I mean. Why would I put over x there? I think that should be over 100. Just rub that out. And now I've got to square this because that's just y. It's y squared dx. Now I really wonder, are they going to just allow for you to quote your calculator answer here? Because then it's easy and that's no problem at all. Like, it says using algebraic integration though, and that suggests they want to see some algebra. That's what it suggests to me anyway. But you know, multiplying this out is actually a bit of a pain. I did like a massive grid. It just seemed like, you know, isn't this overkill? Well, I did x cubed minus 64x I didn't worry about the 100 square because I took it outside and put it under the pi. Plus 400, and then x cubed minus 64x. Maybe I should have divided it by 100 actually. Yeah, is that the easier way of doing it? Yeah, of course, yeah. Okay, let's do it the easier way. Because I definitely didn't do it the easy way when I did it earlier. I did it, but I've just seen the slightly easier way. This happens a lot when I do maths. I tell people a really long way of doing it, and they're like, "Oh yeah, I could have done it like that." So if we write it as 4 plus, it's still going to be ugly actually. No, it's still going to be ugly. No, I've suddenly changed my mind because you're still going to have to square out the grid. If you square the 100, you get 10,000. So write that there. And then when you square out this, and I did it in a big grid, x cubed minus 64x plus 400, and I times this all out carefully. I won't probably do it now because it takes a bit of time, but I'll leave it as an exercise for the person. But what you get when you multiply all those together is you get x to the 6 minus 128x to the 4 plus 800x cubed plus 4096x squared minus 51200x plus 16000 of x squared over 2. No, I'm looking at the wrong line of working. 1 second. And I need that. And then lastly plus 160,000. And you've got to integrate all of that. How many terms are there? What, 6? Blimey. You know, not easy. But I did it. And I checked it on my calculator afterwards. You know, like, also I'm integrating it so I can integrate it now. So I did it, and then all we've got to do next is just increase the power by 1 divided by the new power. Increase power by 1 divided by new power. Oh, I'm getting really messy now. Sorry, that's supposed to be a 128. Yeah. For those of you who are keeping up and have made it through to this far, probably some of you are just looking for the answer. Fair enough, I don't blame you. 200x to the 4. What else did I get? 4096x cubed to the over 3. Minus 512, well, 256 x squared, and then finally 160,000x, and you've got to plug in 8 and minus 8 into that. Anyway, I won't go through the tedious bit where I wrote down some values on my calculator, but in the end I got 904.6 centimeters cubed. That sounds right to me, because look at this. It then says, student pours in 1 litre. A litre is 1,000 centimetres cubed. And there's 100 millilitres left when it's full. Comment on the suitability. Looks highly suited. Looks highly suited. Oh, actually, doesn't look highly suited. Because this suggests that the... Yeah, I'm now completely disagreeing with my answer. So this suggests... Yeah, that the maximum capacity, so maybe my answer is wrong, but it looks right to me. So the student pours water from a full 1 litre jug, oh no, sorry, into the vase, and finds there's 100 metres left. Yeah, no, I did read it right. So this looks highly suited. As the vase's capacity is 900 millilitres. There we go. Well, 904.6. Can we put roughly in there? Roughly 900 millilitres. Apologies for my terrible handwriting. Okay, hope that was useful. Please let me know if I've made any mistakes. I do make mistakes, you know what I'm like, or I say things which are silly, and you love correcting me for it and claiming chocolate and stuff like that. I don't like that. But there we go. So watch out for modelling. If you're watching this and you're doing the A2 stuff soon, yeah, expect the unexpected. Like, don't trust Edexcel. Watch out for modelling questions. That would be my advice. Best of luck. And best of luck as well to the 2 AS students I had who did this exam. Well played, well played. You've survived, you survived. However well it went, the next exam is the most important one. Just push on. Everybody's going to find that paper tough. Well done.